Bon après-midi tout le monde. We have a number of participants still waiting to join us, so I'm going to give things another few seconds, maybe a minute, before we actually get underway. Well, I think we should get going. Once again, bon après-midi tout le monde. Good afternoon, everyone. My name is Jeff Longadoc, and I'm the Executive Director of CASI. And as such, it's my great pleasure to welcome you to the Space Domain Workshop. This is one of the events included in the ASTRO 2020 virtual series of events. As many of you will know, the CASI ASTRO 2020 conference originally was to have been held in June in Toronto. However, COVID-19 necessitated a change in plan. We've arranged with many of the authors whose abstracts had been accepted into the technical program of ASTRO 2020 to participate in virtual online sessions. These sessions are being run essentially as they would have been during a typical on-site conference, although of course at arm's length. Today's workshop is entitled Canadian Space Domain Awareness, Today and Tomorrow. This is longer than a usual session. A normal session would be an hour and a half long or so. This is a workshop. The intention of a workshop format is to give much more detail and more opportunity for audience involvement in the topic under discussion that day. And space domain awareness being the topic today, I think all of you who will be together with us will be particularly interested in the subject matter, and you're going to be well informed by the folks who will be presenting information this afternoon. Workshop is being moderated by Dr. Donald Bédard. Don is a defense scientist at Defense Research and Development Canada, affectionately known by most of us as DRDC. First and foremost, I guess, and before I forget, I'd like to thank DRDC for its support of this workshop. That support is much appreciated, and it should be acknowledged, and I'll acknowledge it again later on today. So now I'd like to give you a bit of background about Don Bédard. So Don joined the Canadian Armed Forces in 1990. He obtained a Bachelor of Science in Space Science from the Collège Militaire Royal de Saint-Jean in 1995, Master of Science in Space Studies from the University of North Dakota in 2002, and a PhD in physics from the Royal Military College, RMC, in 2013. Don is also a graduate of the International Space University Summer Program in 2004, and he holds a Master's Certificate in Project Management from the University of Washington. In 2002, he was posted to the Space Systems Group at DRDC, where he occupied various roles, most notably the DRDC NEOSAT Project Manager, DRDC CSA M3MSAT Joint Project Manager, and Space Systems Group Leader. And on a personal note, it was probably in 2004 that I first met Don, when he presented a paper together with colleagues on NEOSAT at the International Astronautical Congress that was hosted by my organization, by CASI, in 2004 in Toronto. In Vancouver. In 2014, it was hosted in Toronto, again by CASI, so I get them confused. During his last 2 years in uniform, pardon me, he served as the project director for the Surveillance of Space 2 project. Don retired from the Canadian Armed Forces in 2020 and is now a senior defense scientist in the Space Systems Group at DRDC in Ottawa. His research activities are mainly focused on the spectrometric characterization of artificial Earth orbiting objects. So that's Don Bédard. Don, thank you so much for moderating today and for being so instrumental in bringing together this group of experts in space domain awareness. Some of you may already have submitted questions in advance of this workshop. We invited folks to do that, and some of you did do. Comments and questions today are welcome, and we encourage you to participate. If you have logged in with Zoom, you will see a chat button somewhere on your screen, probably in the lower right-hand corner. If you have a question, select this feature and direct your comment to everyone, assuming you'd like it incorporated into the discussion this afternoon, so that all participants can view your input. As moderator, Don will decide when to direct questions to the panel, which ones to select, and also it will be at his option to consolidate a number of comments or questions that are similar, and then to present kind of a rolled up question or comment to one or more of our panelists today. And assuming the necessary permissions are received, CASI will post a video of the workshop for the benefit of those who could not attend today's event. So that's it for my housekeeping announcements and my introduction. And now, Don, I'd like to hand off to you. The floor is yours.
Thank you very much, Jeff. Before I get going, I want to first off thank Jeff Langdock and the CASI team for making this first joint CASI DRDC Space Domain Awareness Workshop a reality. The CASI team was instrumental in helping us organize and coordinate this workshop, this first ever workshop. When we first began working on it in January, we fully intended on a full day in-person event as part of the CASI ASTRO conference, as Jeff alluded to earlier. The plan called for presentations in the morning and then breakout focused discussion groups in the afternoon between 4 and 5, depending on the topics that we would have down selected. But as you all know, in April, COVID-19 forced us to change this plan and adapt to our new reality. Fortunately, with the sudden proliferation of internet video conference technologies and the outstanding support of the CASI team, we were able to still hold this event in 2020, albeit in a reduced form. That said, participation today has blown away my expectations. When I first was handed this task, I was hoping that I'd get 50 people to the workshop in Toronto. Today, last count, we were over 175 participants from all sectors, representing all sectors in Canada: civil, government, military, commercial, academia, and even private citizens interested in this from coast to coast. I'll now begin the workshop by stating our objective today, and that is to initiate a focused discussion on Canada's requirements for practical and usable space domain awareness, or SDA, as it's commonly referred to. The aim here is not to reproduce a Canadian version of events such as the AMOS conference in Maui or the UK military SSA conference. Our aim was to start what we hope is going to be a regular event where we're going to discuss issues, SDA's issues that affect and pertain to Canada. From these discussions, we're hoping that we are going to inform and possibly influence future Canadian national policies and action in these areas. As part of this process and our overall goal, we need to address and clearly provide answers as to why SDA is important, not only to DND and the Canadian Armed Forces, but also to every Canadian space stakeholder, whether they are in the civil sector, Canadian industry, or academia. Let's be clear, achieving or having SDA is not an end unto itself. SDA provides information that policy and decision makers use to deal with situation and events. Military organizations use SDA to support and enable military operations. Governments and civil agencies use this information to operate and protect the national infrastructure that rely on space systems and that can be affected by space weather. Commercial entities use SDA to support and, in some cases, enable activities that provide goods and services that allow our modern society to function and thrive. For its part, academia can employ SDA to conduct research and generate new knowledge for the benefit of our society and all of these aforementioned sectors. So this ultimately, our discussion, which is going to start today and hopefully continue on further events, should not only be focused on technologies, tools, and techniques. It needs to be much wider and include other topics. Many of you have already commented directly to me about the need for Canada to play a larger role in the global efforts to manage the rapidly growing issue of space traffic. That being said, the workshop today begins with presentations from 5 speakers that work in very different Canadian space fields. As such, they're going to provide us with their different perspective on what space domain awareness represents to them and their colleagues and provides within their respective sector. As you've seen in the agenda, we've got representatives from defense, civil, Canadian industry, and even our National Space Weather Forecast Office. At the end of each presentation, we're going to have between 10 to 15-minute question period, where I am going to pose to our speakers selected questions from the audience that I see either on the chat or from the questions that I've received by email, which you are free to do so until the end of this period. Before I stop, and hand over the floor to our first speaker, I wish to point out that we've got one group that's not represented in our list of speakers today, and that is academia. It's not an omission or they weren't forgotten. I really tried to include representatives from academia, but unfortunately, we did not have enough time to include one more talk this afternoon. That said, I'm very happy to report that we've got a significant number of professors, researchers, students, both undergrads and graduates, representing universities from across our great nation. And as such, I'm very much interested in hearing your thoughts and ideas today, either through chat or email, or after this workshop. Feel free to engage me and to connect with me so that next time I can schedule some time for academia. In any case, at the end of this day, participants will have obtained a very broad overview of the state of SDA in Canada at present day and what our plans are currently for the next 10 years. This is, I think, going to set the stage to inform and initiate those focused discussions that we need to have as Canadians on our requirements for practical and usable SDA and what we do with that. So without any further ado, I'm going to introduce our first speaker, Monsieur Pascal Tremblay, who's going to provide us with the Canadian Armed Forces and D&D perspective on space domain awareness. Pascal first joined the Canadian Armed Forces in 1991, and actually our career paths crossed somewhat when we were both at CMR at the same time. He graduated in 1996 from RMC with a Bachelor's of Space Science, and returned to that institution between 2007 and 2009 to get a Master's of Science in Physics with a specialization in space operations. As part of his career as a communications and electronic officer in the Air Force, he held various positions both in Canada and abroad in the US. Most notably, he served as a space systems operator at Clear Air Force Base in Alaska, a senior system controller in the Cheyenne Mountain Complex in Colorado. He replaced me at DRDC in 2009 as the Space Systems Group Leader, where he led not only the group, but the M3 MSAT Joint Project Management Office. After that, served under Director General Space, both as the project director for military communications satellite projects, as well as later taking the role of section head of the communications section. He retired in 2018, circled the planet for about a year, came back to work for AD & Paul within D&D, and started in his current position as the Space Domain Awareness Program Manager last year. So it's my pleasure to welcome and cede the floor to Pascal Tremblay.
Merci Donald, très apprécié. Good afternoon, everyone. I'd like to thank CASI, ASTRO to set up that workshop for us, because it's like Dans has said, it's been a long time discussion at DND to try to get a platform to have that discussion with the Canadian public, industry, academia. We have several other platforms internationally to have that kind of conversation, but having a platform within Canada is so important, and I would have loved to have that discussion face to face. Obviously, last May, having those hallway discussions about where we should be investing, what are the smartest way of approaching this problem set. But unfortunately, we'll try to do our best through this virtual medium, and this is why I'm providing today a very high-level generic deck about how at Defense we are trying to answer that environment. I'm the Space Domain Awareness Program Manager, like Don said, and this is a fairly new position for Defense. There was a need to look at it a more strategic level, and my task is trying to come up with that strategy and trying to answer those hard questions. So without no further ado, again, thank you for having me. I'll bring my presentation up. Okay. So yeah, I guess, first of all, I'd like to say that SDA is not new in a way where at Defense, at least, we've been conducting several areas of the SDA mission in silos. We've been trying to answer and respond to events in space, but in a very uncoordinated way. And now that's why the title of my presentation, moving from SSA to SDA, is so important, because now we have that mandate to look at it. I'm trying to move that mouse. Okay, anyway. Trying to move from a very focused SSA mission to a more holistic view of space. How do we defend the space as a domain, operational domain, even though there's no borders, no specific limits, and knowing that our defense assets are also being exposed to adversaries, I would say, reach. Anyway, so moving to, so the goal of my presentation, like I said quickly, is mainly to generate a discussion around, I guess, the defense transition from a SSA-focused mission area to a more all-encompassing space domain awareness capability development effort. And I'll be presenting, I guess, the various areas where we're going to be spending a lot of efforts over the next years to try to answer that question. So if I'm using the traditional space situational
Pascal,
awareness.
I'm sorry, we're not seeing your slides.
Okay. Thanks for letting me know. I'll share that screen again. And boom. Is that better now?
Yes, thank you.
Okay. So I guess if we're going to more traditional space situational awareness definition, defense has spent a lot of time trying to track satellite in space from, I guess, from big radar cross sections to small radar cross sections, through developing algorithms in support of orbit estimation, doing what we used to call catalog maintenance, now called custody operations in the coalition realm, and also having spending some effort characterizing space object, mainly knowing what these objects are. So we've used the data from the SSA platform sensors to pretty much help us with also conjunction avoidance, making sure also that when we are using lasers, that we clear the space area to avoid damages, and also to provide some some heads up to our soldiers deployed abroad of which satellites is flying over their theater of operation. Okay. I apologize, I'm just trying to coordinate all this. Are you still seeing my slides?
Yeah, we can still see them.
Okay, good. So I think we're good. So let's run with it. So one of the first capabilities that Canada has developed is the Sapphire satellite. I'm sure there's a lot of you that are very familiar with this satellite. It was launched in February 2013. Its main mission is in support of the US Space Surveillance Network, pretty much providing tracking and observation data to the US SSN. The satellite, luckily, we're still operating today, despite its 5 years of design life. Still operating well, surprisingly. And most of the taskings are being coordinated in North Bay through our Sensor Systems Operations Center. And at the time of the contract, it was decided that the satellite would be controlled and operated by NDA in BC. We'll discuss a bit more later down the road about this. But so far, this mission has been quite successful and is kind of I would say, the SSA leader and what Canada is capable of providing to coalition and to Canada. But space has changed quite a bit since I was a space operator at Clear Air Force Station. Before the main hazards were space weather and collision avoidance with other satellites or debris kind of thing. But now space has evolved in a situation where we have adversaries also deploying capabilities capable of interfering with our operations. So that required, I guess, a lot more work to trying to define those actions and I guess I'm sure you've heard several times about space is a contested, congested, and competitive environment, not just because of adversaries, but also because a lot more countries have access to space. They have satellite on orbit. I'm sure you've seen several times those pictures about the number of satellites orbiting around the globe and the various hazards that could happen with having so many players now in space and in a domain that, despite international efforts to have rules and regulations to have some kind of a coordinated, well-maintained domain, it's still kind of a free access, free operating domain, and that's something that defense is quite concerned. But to go back to this slide, where talking about the threat that we are tracking is mainly adversaries developing capabilities to either jam our GPS signals or trying to interfere with our synthetic aperture radars using lasers. There are, I guess, there are some nations who have deployed anti-satellite missile, what we call ASAT. You had an example in March 2019 with India conducting an ASAT test that created a lot of debris. Defense and Canada and the US have been quite vocal about the latest Russian activities in space, using space-based on-orbit counter space capabilities. I guess there's a lot of concerns about weaponization of space, and that new situation now forces defense to look at space quite differently. It's no longer just about tracking objects where they are. It's about also defending our defense assets and also protecting Canadian economy. Has some of those satellite systems is one of your critical infrastructure for a banking system and so forth. So this is why we've embraced, I guess, this new expression called space domain awareness. By naming it, now we are forced to look at it more holistically from the top down, I guess. And space domain awareness now for us forces us to include a more sustained intelligence, space intelligence aspect. Also forces us to be more serious about cyber intervention, cyber activities in space, and also on our ground infrastructure. Space weather, Canada has a long legacy in space weather. We have our NR10 guest today who's going to be talking about it. But from a space operation point of view, we know it happens, but sometimes we find out too late, and we'll talk more about it. And also from a space domain awareness on the defense side of the house, it forces us also to look at the entire, what I call the space domain enterprise. The space domain enterprise includes our ground infrastructure, personnel, data, and this is why this mission is so critical. We also include in our space domain awareness approach a level of decision making. During the time of SSA, it was all about predicting the position of a satellite, and if you had very precise measurements, you were capable of advising or doing some maneuvers of your satellites to avoid collision. Now, if we just to name the ASAT activities by some of the countries, now the decision making is quite rapid. For example, an ASAT, by the time ASAT is launched and detected, we have more or less 10 to 15 minutes to react to that activity. So having a decision-making process that is well integrated with the right type of information, fused information, available information, is so critical to protect our space assets. So we are trying at Defense to deploy new sensors and to continue to support the SSA mission, but also enabling our space domain awareness activity. I've talked about SAFAR, and we do have on the R&D side NeoSat as a platform to help us advise on new satellite capabilities for the space domain awareness. NeoSat is still operational. After the design life of 5 years, it was launched at the same time as SAFAR, and now we're looking into a replacement for it. You might have heard also about the Surveillance of Space 2 project. The Surveillance of Space 2 project is, I guess, a follow-on project to maintain a presence in space to replace SAFAR, but also add a component on the ground. A component on the ground that we hope will be able to maintain our abilities to have a more long-term presence without any gaps due to failures or project delays. The Surveillance of Space 2 project is ongoing. Now, during this presentation, I won't talk much about Surveillance of Space 2 project, but I'll tell you this. Surveillance of Space 2 intends to deliver, like I said, GBO sensors and space-based sensor. The Surveillance of Space 2 will support both national and allied space surveillance mission, and is currently in a option analysis phase. At the end of this deck, I have contact information if you have any questions about this project in particular. But the aim of this presentation is not to talk about capabilities per se, but more about the vision that we have for SDA. And we hope that the Surveillance of Space 2 project will come up online soon and be able to help us answer some of our deficiencies to operate in the space domain. So like I mentioned with the SDA introduction, space intelligence is a huge component of the space domain awareness. I look at space intelligence as a simple mathematical formula There are various formulas out there to express what could be a threat, but I look at it from I guess from a opportunity basis. If capability meaning that does that nation have the tools, the knowledge, the education program? Actually, do they have the satellite launch in space or ground tools or capabilities to interfere with our operations? That's the capability piece. The opportunity piece is kind of what we were doing with the SSA, where space situational awareness was telling us, is the satellite close to our critical infrastructure in space? Is it within a range that could actually interrupt our activities? And then I would say this is why I had that little bubble in the darker blue. Intent is the piece that is the most difficult for us to assess. Once you add all these variables together, this is where you can define a threat. And the way that we're planning to have a more robust space intelligence program is to continue investing in our collection of imagery, communication intelligence, electronic properties, interceptions, also human intelligence, and also the open source domain. The open source domain is an interesting areas where defense could do better to gather information and being able to extract what is necessary to help us define intent. Space cyber security. I've mentioned space cyber in my intro definition because it's so critical to our operations. Like defense have assessed that cyber security might be the areas where it's the most, that space systems and our infrastructure is the most vulnerable. We need to be able to have a better grip on protecting our IT infrastructure and also protecting our data. Cyber itself for the defense community is a domain like space, is a domain like air and Navy and land. But I want to mention cyber here in the space domain awareness because these two areas is going to have to work together very closely. There's no as the picture I've put up there, it shows that satellite systems and information technology and information management and information networks is so closely linked that these two domains have to be treated the same way with the same standards and with the same assessment of threat. So examples of type of activities happening on the cyber domain. Some of you must be very familiar with this, where you could experience spoofing of sensor data, corruption of sensor systems, jamming through the information management networks. You have also injection of malicious codes and conducting denial of service attacks. These are activities that we are experiencing today, and through the space domain awareness, we hope to be able to develop capabilities and monitoring also capabilities to detect and react quickly to those events. Space weather. Space weather is I'm an ex communication officer, and I've spent a lot of time in the RF world, electromagnetic spectrum, and there's a little bit of magic to that. But space weather, understanding space weather and being able to use the data from space weather sensors efficiently and will help us to better, for example, identify anomalies on board a spacecraft. Often we have anomalies, and then we are trying to figure out if it's an internal failures, or if it's adversary actions, or just simply a single event happening on one of our electronic processor. But being able to have sensors deployed throughout on the ground and in space will allow us to have a better common operating understanding of the space weather effects in space. Also, space weather help us to have much robust satellites where we are considering space weather in our satellite design through components lifetimes and potentially adding shielding requirements. Space weather also affects our day-to-day operation of our space assets, where most of our space assets are being controlled through the RF radio frequency spectrum. And the radio frequency spectrum is quite susceptible to the ionosphere and other effects. Some of our frequencies, the UHF frequencies, for example, or HF frequencies, are very susceptible to space weather effects. So, like I said, to achieve accurate and reliable space weather services, we need to think about adding and compiling information from more space weather sensors. And I'm sure you're going to hear a lot more about from our NRCan rep today. Another area where we're going to be spending a lot of time is also understanding the entire defense space enterprise. Our defense space enterprise, in the past, like the Sapphire mission, we used to just look at pretty much the satellite. The satellite itself is TT&C ground station, and the link back to our data storage area where operators would use the data and being able to update the catalog. This is my time up. Sorry. So the space terrestrial infrastructure, we're going to be going through the entire scope of it, going through personnels, making sure that are well trained, also looking at all our facilities, making sure that they are secure, they have redundancy and all that. I've put out the list but an area where we are spending a lot of time is the supply chain integrity. And this is potentially something that Canadian industry is very preoccupied, is that a lot of our, I guess, space systems components or satellite support equipment is purchased outside of Canada, and we have not a lot of control over who's going to buy that foreign company, or if that company is going to sustain spare parts and so forth. So having some sovereignty over our supply chain and making sure that we have redundant access to other spare parts or other equipment to support future missions is also very important. And without saying that contracted services is so critical to our defense operations, where I was in the SATCOM business before, and we are contracting out a lot of our SATCOM services from industry, and these services are the backbone of our operations abroad and domestically. So the last area that I wanted to mention about space domain awareness is the decision-making process. So I don't want to teach anyone about how we conduct decision-making. This is why I just brought the traditional OODA loop graphic here about observe, orient, decide, and act. So we are looking to include within the space domain awareness program formulation a decision-making component. There is a lot of activities going on, from a machine learning, artificial intelligence, to expedite the decision-making, because with the venue of big data and being able to crunch all that data and making it usable for decision makers to develop courses of actions and being able to task very rapidly their unit to react to an event, it is so critical to the space domain awareness. So on my last slide, I just wanted to, this is not an exhaustive list of all our collaborations and cooperation, but I wanted to highlight that at Defense, we need everyone. We need other government departments to collaborate with us, and you'll hear presentation by CSA and GAC, and on that where we need to better work together, as the SDA is going to involve a lot more than just defense. But at the same time, we are very well integrated within our Five Eyes network. Right now, we are part of the Combined Space Operation. It's a 7-nation MOU, Memorandum of Understanding, that includes also France and Germany. And through that Memorandum of Understanding, we hope to be able to operate within a more global reach, helping us to develop a better space domain picture and reaction to events in space. So because of time, I'm going to leave it there for questions, if any. I'm going to bring up the slides about any questions about the Surveillance of Space 2 project that I'm not going to discuss today for your information, but I guess, Don, I'm open for questions. Thank you.
Great, thank you very much, Pascal. Thank you very much for the great presentation. I did receive a few comments about your nice beard, which is a tremendous change from your previous military career. So the first question that I've received, actually I've received a few versions of this one, is some of our participants are wondering what types of SDA discussions have been taking place with agencies and other government departments in Canada, within our government, and perhaps even with industry within Canada. Is there a delineation of responsibility with other governments' departments for SDA? Over.
Okay, thanks, Don. So this is a very good question, and I think you're going to hear also from Michel this afternoon that same concern or that same observation that from a Canadian defense perspective, because of our close relationship with the US, we've been operating in the space domain really from a military angle. You've seen over the last last 2 years, a huge shift in the US and in Europe to try to develop a satellite tracking management agencies that would help industry and other operators outside of the military to have precise data about the health and status of the satellite, having better data about the tracking of the satellites, and being able to provide that data more quickly and more efficiently. So in Canada, to go back to that question, the conversation is just starting. I'll be frank with you, it's just starting. Defense is willing to collaborate, obviously, with other government departments. I think it does require also some will from the government to also look at this problem set. And no, I guess it's just starting, and we're willing to work with the appropriate agencies to share that information and be able to work in that space at the unclassified level, if you say.
Great, thank you very much. A follow-on question to that is, I'll read it out loud and then I'll maybe just frame it just a tad differently. What coordination is being done with our close partners, Five Eyes, and the additional nations with whom we're collaborating in the CSPO, with respect to what part or niche here that Canada may play in the future? So in your discussions with your colleagues at the international level, is everybody trying to essentially not overlap each other? Are nations taking niche areas of expertise to making sure that the whole arc of fire is completely covered?
That's a very good question. Under CSPO, we have various groups that looks at that problem set. So CSPO has a very strategic level where, for example, you must have seen several tweets from the US, the UK, even from our Canadian leadership here, blaming Russia and about the activities in space. And this is the kind of response that we've developed under CSPO, a coordinated response with a national messaging. from a system side of the house, making sure that we're not just all working in silos or having duplicated systems and spending all our money in the same area where we are leaving potentially space weather and other areas without any investments. We have also working groups under CISPO that looks at that exactly. We have working groups, for example, that look at the long-term strategic level. We're looking, for example, up to 2035 right now, trying to identify each of the nation's programs and trying to influence national acquisition initiative. Obviously, the CISPO is not a decision-making body. The CISPO is a kind of a guiding body. So we have to work with the nation's internal programs, but we're trying to expose areas where it needs a bit more love, a bit more investment. And we hope by identifying those areas of that we might be lacking exposures or sensor data, that some of the nations will find will jump on these areas and invest a bit more. So we can all contribute and we can all operate in space, sharing information that is valuable for everyone. So yes, right now there is some duplication. I think Canada is a good niche area with SSA. The Sapphire mission is quite successful. With the Surveillance of Space 2 project, you see that we are continuing investing in that, but we want to do more. We want to do a lot more, and we have so many centers of excellence in Canada that we need to be able to identify those and bring those up front to our allied partners and saying this is where we can make a difference. And this is part of also my role and the R&D role on your side, Don, to be able to identify those areas.
Great, thank you. I'll ask you one last question, and this is from Professor Jaku at McGill, International Space Law. And his question pertains to the information acquired by SDA. In my introduction, I alluded that academia can research and provide benefits through the new knowledge they generate to either improve SSA or the actions that we want to deal with SSA. And he's asking whether the information acquired by SDA systems will only be made available to defense community, or have you started thinking that this data can also be made publicly available to some degree, not only for the commercial sector, but also to academia to enable that research?
No, that's a very good question. And one example, for example, with the Sapphire mission, I could say the majority of the information is unclassified and is feeding the satellite, the US satellite catalog that most of you are aware with CelesteTrack and spacetrack.org. So we are already contributing quite heavily to the public domain through the US, but with our new initiative in SDA and with our ambition to collaborate with other government departments, it is definitely our intention to share more and more information with the public and other agencies. We feel, and this is why CISPO has come up, we feel that that no one can operate and manage space alone. We have to do it as a team. And this is why we're trying to bring everyone into this problem set, because the environment has definitely changed. It's no longer about launching a satellite with no defense and hoping that the satellite is going to continue to operate. It's about, I guess, core orbital activities and so forth. So, and it involves everyone, as defense is mainly leveraging, for example, satellite communication from industry. We need to share information with industry about the states of the space domain.
Merci beaucoup. Thank you very much, Pascal. With that, I just want to make something clear. I received a question. I maybe misspoke or wasn't clear enough when I introduced you. In 2018, Pascal returned to D&D as a civilian working for ADM Paul, and then in 2019 transferred over to the RCAF, the Royal Canadian Air Force, and he is now working for Director General Air and Force Development in his present role. So hopefully this is now clear. I'm starting to receive lots of questions, and this is great. This is exactly what we were looking for. For your information, I won't be able to ask all of them in the interest of time, but what I am doing is copy and pasting them with your name, and I hope to get to these questions in an after action report that I am going to draft after this event and that I'm going to make publicly available, where those questions are going to be answered. If not, feel free to come in contact with me by email, through LinkedIn, and let's engage in that discussion. I'd like to hear from you and either put you in contact with the people that might have an answer to your question or might want to hear about your ideas. So, encore une fois, merci beaucoup, Pascal. If you can switch your screen off, I'm going to now introduce our next speaker, Mr. John Holland, who's going to tell us about Telesat's perspective with respect to space domain awareness. He's been at Telesat Canada for just over 15 years. He works in the Spacecraft Operations Division as a Flight Dynamics Operations Specialist. While working in the Spacecraft Operations Group, John gained experience in both GEO and LEO operations, including flight dynamics operations, operations coordination, spacecraft control automation, optimizing data analysis, and space situational awareness operations. I personally sought out a presentation from Telesat. As you probably all know, within the next few months, they'll start deploying their LEO constellation, which will make Telesat the Canadian operator with the most satellite in Earth orbit. They will have to deal first and foremost with SDA and what to do with this information. So I'm very, very happy that they accepted the invitation to come and present here today. And without any further delay, I leave the floor to you, John. Thank you.
Thank you very much, Don. And I also want to thank the CASI team as well for the invite to come. It's a privilege to share from a commercial operator's perspective what we have to deal with. Sorry, I'm just getting a message here. Just to double check, can everybody see my screen? Can I get a confirmation?
Yes, we can see your screen and we hear you well.
Okay, perfect. Okay, yeah, so it's a privilege to be here again. The space domain awareness is somewhat new to commercial operators. The subset space situational awareness we've all dealt with for some time. So really we wanted to come here to start posing questions and see what the industry, whether it's defense, academia, or experts in other fields, to see what they have to say, and for us to find ways how to incorporate this into our operations. This is the agenda here. The basic idea is we'll discuss how we see SSA and SDA, what we're currently doing for SDA operations at Telesat, and how we see the path going forward when we get our LEO constellation in place, and how we can potentially contribute as well to the overall goal of SDA. So the first thing, just to give you a little bit of history of Telesat, we have been a GEO operator for over 50 years now. I believe we're going on 51 years now. And we are now a global operator as of about, I'd say, 10, 15 years ago. We operate 24 geosynchronous satellites, 7 of which are some other customers, 16 of which we actually own and operate ourselves. We also, 2 years ago, we also launched the initial phase of our LEO constellation. It was a bring into use mission, but we also have been quite busy using our LEO phase 1 satellite to do demonstrations for equipment manufacturers and supply groups and service providers as well. So we are quite busy, and our domain is getting rather large. So when Don and the CASI team came to us, he asked, what do we do for space domain awareness? And that's not typically a term that we use at Telesat. We've only just adopted the space situational awareness domain, which to us is space debris conjunction analysis and collision avoidance mitigation. And we've been operating at Telesat right under that MO actually for a few decades now. It's something that we've wanted to better over the years, and it has been an evolutionary process. But from Telesat's perspective, when you mention a space domain awareness, that is new to us, and our definition of the space domain awareness is more of a proactive operational approach to monitor and control our localized space domain. So whether it's protecting our satellites or our assets physically, or protect the rights that we have for the radio frequencies, or some other aspects as well that we haven't really thought of, but we'll rely on the experts, such as you guys, to let us know. So we believe that the SSA is now a subset of space domain awareness. So from that perspective, our operations can certainly it can probably evolve over time, I would say, once we get more feedback. So what do we currently do for SDA? And it is our Space Situational Awareness Operations, our SAOps. We currently work with not CSPOC directly. We actually use some second-party data providers to help us with our SSA operations and our collision avoidance operations as well. Some of them are commercial entities that we pay for, while others are giving us their services pro bono. So the main primary data provider for us right now is MIT Lincoln Labs, that has access to the CSPOC SSN database and the special perturbation data that's there. And they also have some of their own terrestrial systems that can track and hone and kind of refine orbits for us for incoming drifter objects. And I put drifter in quotes because they're mandated to only provide that data for decommissioned satellites or known debris that's coming near our space domain. But that still leaves a bit of a gap where we have the CSA supplementing as a backup provider that screens all our CDMs with their CRAM system, the conjunction, risk assessment, and mitigation system, I believe, which I believe the next speaker will talk about probably later. And they kind of fill in the gaps. Those screen our operational and unknown secondary objects that are coming our way, and they kind of provide 100% knowledge for our domain. I just want to give an example. Actually, 2 weeks ago, right, we had no input from our primary provider that there was a satellite coming our way. And at first, we thought it was just an operational satellite that was mistagged. But as we used the CRAM system and we heeded their warning, and as we did a little bit more information gathering, we realized that it was a defunct satellite that just sort of became disabled in July and was coming by one of our satellites. So yeah, so those two providers complement each other and provide us a good overall view of our particular domain. We also have partnered with CanSPOC as well, who give us special perturbation orbits for our Telesat fleet, which comes in quite handy because we can use that to calibrate our ground system data as well. So overall, our space situational operations is pretty much refined, I'd say, at this point for our GEO fleet. And the key to making it efficient and optimal is to incorporate it in with our station keeping operations. So we usually have these routine maneuvers we have to do to maintain our GEO orbits. And with long enough lead times that we get from MIT Lincoln Labs and CSA and CSPOC, we can incorporate those into our routine operations, which saves on a workforce hours. And it also saves on fuel budgets. So, so refining these processes have a big help overall to our space domain awareness and to our fleet health and longevity overall. But it's not without those partnerships would we have been successful. So from GEO to now LEO. So as Don noted, we are moving forward with our LEO constellation, which will see close to 300 LEO satellites in orbit by, we're hoping, 2023 and onward. So about a quarter of those satellites are going to be what we call polar satellites, which will they will orbit the poles, and they will provide complete global coverage at all times. But to supplement geographical regions with higher demand, we're also launching what we're calling the inclined satellites, or the inclined constellation, if you will, that supplements the polar constellation, and those will be at an inclination of around 50 degrees and provide a bulk of the bandwidth that's used. So given that 300 new satellites in a LEO environment, a much more dense, a much more busier environment than GEO, we definitely need to get our SDA in order. And right now, what we're expecting for our requirements is our SSA ops, and we want to kind of mimic how we're doing the GEO operations right now. So the key goal is to integrate our collision avoidance and conjunction assessments within our station keeping operations. And we hope to have lead times, and this is something for discussions in the future, we hope to have lead times of up to 7 days, because that will fit probably into our routines. And those will require orbits that have a high confidence in accuracy, so we can make reliable decisions on our operations. And another aspect that needs to be tuned up a little bit is the screening processes as well. So the databases and the number crunching that's involved in order to screen for conjunctions for currently what's out there is quite frankly mind-numbing, and we have to give kudos to CSPOC and the other third-party entities that are out there that do that job. But for us to make space situational awareness operations viable for us, we need to have quick turnarounds on screening and rescreening. So if we decide to do an avoidance maneuver, we have to pass it back to CSPOC, and they'll let us know if that potential collision avoidance maneuver will get us into more trouble or get us in the clear. So that's something that we want to work towards, and we hope CSPOC can provide that. But there's other third-party operators out there as well. There's other third-party operators out there as well that can provide those services. So we're also looking for those and discussing our requirements with them as well. The other thing that we want to emphasize is some people may be aware that the Department of Commerce in the US, I believe, is contemplating a space traffic management system. But that is basically something that we do want to partake in, because as mega constellations will get launched, there's going to be the LEO environment is going to be very busy, and we need more of an industry standard on sharing our orbits and our ephemerides to make sure that when we make operational decisions, we're doing it with the best possible data available. And as of right now, everything is voluntary. So those that do share their ephemerides with CSPOC, it's a voluntary program. And there's other entities out there like the Space Data Association, but they have membership fees, which for some operators could be a bit of a hurdle. So they may not have a complete clear picture with voluntary like ephemera sharing. So it would be nice to have something from that's regulated by the industry and is mandatory to share this information, especially with these constellations coming up. So from the constellation perspective, what we see as SDA is the collision avoidance so far. And we're currently looking for more partnerships out there to help with what will certainly be very busy. But as Dawn came to us, and as we've heard rumblings in the past as well, there is more to our space domain awareness definition. So we're going to have to, as not just us as Telesat, but as an industry of commercial operators, we're going to have a better understanding of what is the scope and the concept of operations to address the SDA. You know, what is the overall issue we're tackling? Is it just malicious intended right, like events from other actors, or just as Pascal was mentioning earlier, and what we'll see in another presentation, space weather, which is something that we are monitoring, but we will have to incorporate more, right, as the industry kind of reminds us that that is quite necessary to do so. So what we would like to see is a kind of direction in education from basically all of you. And in order to mitigate new issues that pop up in the space domain awareness, we need to also act within our commercial capabilities. So, you know, right, we need to make sure that the solution or the mitigation doesn't outstretch our capabilities as a commercial entity. You know, like one example is with space debris. You know, you could armor up your satellites and make them weigh a ton, but the cost is going to outweigh the possibility of that actually happening. So we're hoping that as the SDA gets defined and what needs to be done to tackle those issues, we hope to address those in an optimal way, right, within our particular budgets. So the other thing as well, we need to also be aware of how far this stretches. So if we were to address space domain awareness and the issues that are defined by it, how is it going to affect commercial operators as a whole? Because we have a number of control centers and operational centers. So I represent the SOC, the Spacecraft Operations Center, and we can control the physical domain around the satellite. But our other instances of space domain awareness issues related to, say, RF, right, like frequency, like interruptions, and should our network operations center also be a part of that as well? And we also have a third control center, which is our cybersecurity center, which will be initiated with our LEO project. So do they need to be involved? And I think the answer is yes, but we need to see the severity that these have that these control centers need to act with and what issues need to be addressed, or just a concept of what those issues need to be addressed. But basically, overall, Telesat is certainly willing to expand our partnerships to tackle what we see as a new issue, which is to expand the space domain awareness preparedness of Telesat. So, what do we need overall for this to happen? And I have Telesat, what do we need? But maybe representing all commercial operators here right now, what do we need? And again, we need a definition of what is SDA, and not so much a definition of what it is, but maybe just what some issues or events as examples could occur. And that could get us brainstorming how we could address those issues, because we are very much aware that it is an evolving domain and issue. So having just the insight from the expertise in the industry will be a big help. But then the question is how do we get and tap into that expertise in the industry? And one thing that we have discussed in the past is to have a liaison. And I know there might be some people here globally, but focusing as a Canadian operator, we would certainly look to D&D and their associates for this to be a focal point in conversations on upcoming SDA issues and things to consider, or perhaps that's more a CSA thing. But if there was a focal point in communications that we could use, our operational teams can utilize that contact to stay on top of what's required. The other thing as well is not just to have that one particular liaison, but to have things like this workshop, this CASI workshop, where we can create a network as commercial operators with those in academics, with those in different government branches, or those D&D. So we can stay on top of what's required with the SDA and the issues that we'll face. One thing that would be nice, and I just want to give an example, back in 2009, when the Iridium and Cosmos collision happened, Telesat already had a good GEO process in place to deal with collision avoidance. But when it came to LEO, we didn't have any LEO spacecraft at the time, but we didn't know, anyway, how to deal with that. And we were consulting on the RadarSat-2 program. And it was because of the network in operations that we had with the CSA, with MDA, who owns RadarSat-2, and with SED, who controls at RadarSat-2 for the CSA. We created a network and were able to share knowledge and create what I believe a very sound understanding right after that particular incident. So to have workshops like this where actual operators in many different sectors, those that are, on the ground floor of things actually happening, to create a network and to have tag ups and workshops would be a great benefit to address SDA moving forward. The other thing as well is how can we contribute? So once we do have this network set up, we could very well be a beneficiary to the SDA operations that that everybody has set up in the industry. But how can commercial operators also contribute? Aside from just being present and sometimes giving our perspective, can we actually physically provide or through some sort of partnership provide actual data through our ground infrastructure, through our current in-orbit assets, or things like hosted payloads and things like that. So Telesat definitely believes in this movement to a more secure SDA. So if there are those in the industry who think we can contribute in certain ways, please let us know as well. And the other thing is we need a roadmap overall. And whether it's just, you know, somebody like a focal point in the industry saying this is how it's going to go, or really just some thoughts and some foreshadowing of events that could happen. If we have a good idea of how it's going to move into the future, we'll be able to plan our operations around that and hopefully be able to mitigate all situations that could crop up, or at least know who to come to with our network, how to potentially mitigate or soften the blow, right, like under certain circumstances. So so yeah, so that's how, from a commercial operator, that's how we see the SDA evolving from our perspective. So yeah, that's everything I wanted to share in this presentation. But if anybody has any questions, I will certainly be open to answering those.
Thank you very much, John. That was very interesting. And I've got tons of questions, but I'm going to ask those that I've received so far. The first one is from Michael Maloney. And he was asking, and there's a few of us that are wondering that, is Telesat intending on providing real-time orbital ephemerides on your LEO satellites to CSPOC or eventually the Office of Space Commerce?
Yeah, the answer to that is quite simple, and the answer is yes. We're currently doing that with our GeoFleet. We just found out that we weren't making them public through CSPOC, right, the ephemerides that we're sharing. But we did rectify that issue about 2 or 3 months ago. But the intent was, and always has been since the incident with the Iridium Cosmos, for Telesat to be open with their orbits and to share as much as we possibly can to the industry.
So when you say public, that means that even though you provide the data to CSPOC, then people down the road, such as me as a researcher, I might be able to get access to these ephemerides?
That is a good point. It will be through CSPOC. I don't really see a concern about sharing some of that data to the public for research purposes. But right now, when I do say made public, it is through the CSPOC website, because those people that have access are already vetted to receive that information.
Okay. And actually, during your presentation, you piqued my curiosity. At one point, you stated, and I might not paraphrase correctly, but it would be nice to see regulation and mandatory, I guess, behaviors. So right now, I guess you're dealing with a US organization, right? The CSPOC. Eventually, space traffic management, because of Space Policy Directive in the US 3, is going to migrate to the Office of Space Commerce, and they're going to handle space traffic management. So I presume you're going to be dealing with them in the future. Would Telesat like to see, or has given thoughts that, you know, they'd like to have a Canadian government institution between you and the US organization that you're dealing with? Or would you rather to keep it as simple as possible and just have that direct line of communication?
Yeah, that's a good question. Overall, I'd say it's whatever's most like advantageous to make sure that the safety of the space domain stays sound. So we know by passing data directly to CSPOC that it will get passed out right, like quickly to owners and operators and whoever else has access. But if there's an intermediary step, perhaps to go through a Canadian entity, we would certainly be open to that. Right, we would like to see it still be a quick process to make sure that those who need that information get it. But the other thing as well is, right, we very much do want to create new partnerships as we move forward with the Leo constellation, right, we realize that we are going to need help in operating and keeping the safety of this. So if there is a Canadian entity there available, we will certainly want to partner with them as well.
Great, thank you very much. And then one last quick question, and this is from an astronomer that I've been working with and who I'm extremely jealous of. He's by day a nurse on the Hibernia oil platform, and that night he's doing observations for me, contract observations of the Intelsat 1002. So he's remotely using his telescope in St. John's to look at satellites for me. And the question that he's got for you today is, with all of these satellites going up in Leo, they're, well, creating light pollution, a different kind of light pollution that we've been used to in the past. Is Telesat addressing that in any way or shape or form?
Yeah, so we are aware, right. We've been made aware, like obviously with Starlink, when they when they initially launch, right, they are quite visible. That Starlink trains that you see. So Telesat is aware of that situation. We believe that where our satellites are going to reside, it shouldn't be an issue because we're going to be about twice as high as where Starlink is. So we're going to be at about 10,000 and 15 kilometers and 13,050 kilometers above with our two different types. So we don't believe from an amateur astronomer perspective that is going to be an issue. With professional astronomy, right, where you have much larger aperture sizes and you're seeing much more, yeah, we understand that could potentially be an issue, but we hope that they would be able to mitigate that. Yeah.
Thank you very much. Once again, thank you very much for your time. I want to remind everybody that if you still have questions for John, keep sending them to me. I'm regrouping them into one document, and which I hope to get to after this workshop. So thank you, John. If you could switch off your screen, and I'll introduce our next speaker, Michel Doyon from the Canadian Space Agency. Today, Michel is going to be, actually is representing two organizations, the Canadian Space Agency, to which he returned just a few weeks ago, back in his old position. And previous to that, he was with Global Affairs Canada. So today he's going to give us a Canadian civil perspective on SDA from these two organizations. Michel Doyon has been working for the Canadian Space Agency since 1998. He occupied various positions in technology development, program management, and since 2009, satellite operations. Over the last 18 months, he was with Global Affairs Canada, or GAC, and he's now back to CSA managing flight operations. So with no further delays, I'll leave the floor to you, Michel.
Thank you, Don. Good afternoon, everybody. Very interesting subject so far. Thanks, Don, for inviting me, CASI as well. So just to complement a bit what Don was mentioning, during my assignment at GAC, I managed the Remote Sensing Space System Act and International Space Security and Policy, and I'm now back at CSA to manage flight operation. Among other things relevant to this topic, I was part of the team with Vicar Abassi and Robyn who created the Conjunction Risk Assessment and Mitigation System, CRAMS, like I think John mentioned it earlier. It processes and analyzes conjunction for over 70 space assets, Canadian, international, government, industry, academia. And I've also been closely involved in UN COPUOS development of long-term sustainability guidelines on the technical level and policy level. I guess we cannot talk in this forum without talking about NEOSAT. So I've been leading NEOSAT operations since 2013 with the CSA staff, as well as industry, this manufacturer, MSCI, and our operator on site, the SED. So we've been working hard to get the best of the satellite and in close collaboration with DRDC. So this presentation will present a bit my experience in both functions at CSE and GAC. Just to be clear, you know, and I think that's what's happening now, but this forum is a workshop to share ideas, different point of views. So I structured my presentation to highlight facts and stimulate discussions and ask questions rather than taking a government position. So with that in mind, we'll start. So this is a typical slide from NASA, and I think it's pretty useful to see. The key message here I want to show is you take the slope of the first 45 years and the slope of the last 4 years of increasing space object. One is the double of the other. So the last 4 years here I've seen a slope twice as much as the beginning here. So this is increasing number of satellites, and we're seeing it, you know, with recent launches. In terms of mass, you know, the key message here is the mass in space steadily increases, and you know, mainly due to spacecraft and rocket bodies. So this is pretty impressive when you look at the trending. In terms of trending, a bit of stats. In April 2020, there were about 2,600 active satellites, about 1,300 from the US, 800 from the rest of the world, 360 or so from China, and 169 from Russian Federation. We're seeing a steep increase of those satellites with the mega constellations, you know, coming up. There are several satellites that are launched every month since January. So the population doubled between 2012 and 2019. Just the last year or so, more than 600 satellites became active in space. So we are at a point where things are changing significantly. So there's a lot more things in space orbiting, and it calls for at least asking questions and being better organized. So from a civilian perspective, space situational awareness is not just space debris, it includes space weather. I think we have a speaker after me on that. Objects orbiting space, whether they're artificial or like debris or active satellites, but as well near Earth objects or NEOs, natural space debris. And as well, there is always this component of intelligence, but this is outside my stream, so I'm not going to talk about it. All of these create hazards. So space weather, like the rayonnement, the X-rays and so on. It affects civil as well as military satellites, collision probabilities and outcome, the same thing, re-entries. So these are all elements that need to be monitored or understood from the SSA perspective or space domain awareness. I'm not going to talk about the military ones, but they are also there. So terminology, I think it was also mentioned by previous speaker, SSA, at least from a civilian perspective, includes not only space surveillance and tracking, but also space weather, near Earth object, and so on. It was more like in a passive approach or monitoring, detecting, identification of objects. Now with this increased population, activities, and so on, space domain awareness, so today's subject is there. It includes, of course, elements of identifying, characterizing, and understanding what's going on, whether it's passive or active. Leading to that, with the increased, I guess, activities, we can ask, should there be space traffic management to, better plan, coordinate, synchronize activities on orbit to make sure that space remains safe, stable, and sustainable for the future and for ongoing space operations. The US, as in their Space Policy Directive 3 in 2018, has been calling for space traffic management. So these are things that we cannot ignore, and we should be mindful and continue to discuss and eventually take actions. The space traffic management challenge basically is like air traffic control, except all objects are traveling more or less independently at 8 kilometers per second in all directions with little or no position or velocity control. I think that was a nice definition that I took from Secure World Foundation. Another element to consider is contrary to airspace, where there are borders, there are no borders in space. So in order to come up with something in some regulation or some constraints in space, all spacefaring nations agree on the requirements. There are new international space laws and regulation that would need to be created and approved, but again, consensus, and it's not only one country that can do it. This sometimes can pose challenges to spacefaring nations, new space actors, and other. It's a complex picture, and not only technical element, policy, programmatics, and so on. So it is not simple, but as activities increase significantly, something will happen at some point. Just some food for thought. Should there be identified or managed zones in space, some controlled or some uncontrolled, so that space actors could select and meet some requirement depending on which zone they would go, and this with the goal of ensuring space safety and maintaining access. With what's in space right now, there is a certain percentage of threatening debris that should continuously and permanently be managed because of the threat they represent and the impact it could have on one operator or even on the overall operations community. Should there be additional restrictions to the new generation of satellites, for example, requiring propulsion or tracking reflectors and so on? Well, it's more a question, because what's the impact on developing nations? Should they pay for what's already in space now? Would it limit access to space to some groups or organizations? So we have to be careful and find a right balance on that. And these are subjects, again, that needs to be discussed nationally, internationally, and to come up with ways of maintaining, let's say, a long-term sustainability of space activities. The government of Canada is committed to the peaceful exploration and use of space for the benefit and in interest of all humankind. From a civil perspective, we use space because it generates socioeconomic benefits. We use space for scientific discovery, commercial activities, government exploitation. The aspect of space domain awareness, is to make sure that assets are protected or will continue to deliver their services and operations will be maintained. From a foreign policy, using my previous hat, like the global affairs aspect, the elements of global assistance, international support. So being aware of what's happening in the space domain contributes to that. There are treaties and obligations that the country is signatory or needs to be compliant. So again, having awareness of what's going on allows us to meet those obligations. The military aspect, I think it's been well treated by Pascal, so I'm not going to talk about it. But the key message is there is a diversity of players, and it calls for coordination, at least at the government level. Some of the key stakeholders, we have CSA, DND, GAC, we have ISED, NRCan, possibly Public Safety and Transport Canada. And of course, we have other space actors in Canada, universities and industry, but from the government perspective, I think we should consider or could consider some coordination at the government level. Give a bit of perspective from the international framework. A lot of the international framework has been created in 1970s, of course, with possibly a different mindset of what we are today, 50 years later. There is the Outer Space Treaty, the Liability Convention, registration on the convention, the registration convention, etc. The more recent years, I think I mentioned earlier, the US issued their Space Policy Directive 3 on space traffic management. Another very significant accomplishment in the recent year, the 21 guidelines for the long-term sustainability of outer space, basically covering elements of policy and regulatory framework for space activities, safety of space operations, international cooperation, capacity building and awareness, scientific and technical research and development. Those guidelines are voluntary and on a voluntary basis. So they're not legally binding, but still create some sort of recognition and commitment, a soft commitment by international, by other countries, basically. And this was agreed to by more than 80 countries. And this was sanctioned at the United Nations General Assembly last fall. Another significant aspect of this subject today, NATO identified space as an operational domain about a year ago. So again, a lot more and more interest in space, what it can do and so on. So these are all elements sort of giving additional flavors to the international framework. Still in discussions, there's still a lot of discussions. There is a resolution in preparation to reduce space threats through norm, rules, and principle of responsible behaviors. Will it go through? We don't know yet, but this is in preparation for the fall. There are more and more discussions on should there be norms of responsible behaviors. Space is a peaceful environment, so how can we tackle that? And different groups, stakeholders have different interpretation of what's responsible or not, or what actions should be taken. Again, these are all elements where space domain awareness can contribute to help identify those things. Still in the international forum, there is a long-term sustainability working group 2.0 that is being discussed. Will it take place or not? We'll see, but a lot of traction on this right now. So more nationally, if I can say, policies and regulations. In Canada, I think these three are the main acts or regulations. So the Aeronautic Act, the Radio Communication Act, essentially spectrum management. That's a key one because, as you all know, without RF, you can have a satellite in space, but if you can't talk to it, it brings it a bit less attractive. And also the Remote Sensing Space System Act. So these are the three main ones. With space activities burgeoning and increasing significantly, the Canadian Space Strategy has highlighted the need for Canada to review the regulatory framework for space-based related activities to ensure that they provide timely responses for industry, maintain strategic oversight for national security, and enable commercial growth. So there is a hook there. Discussions will take place. On the technical or more operational aspect, an increased space domain awareness calls for more space investment. Should there be more sensors? Should there be ground-based, space-based? Should there be space traffic management? Answer can vary. Who should pay for that? Should it be operators, countries? Again, having more access to space domain awareness information is great. there's a cost to that. So how can it be managed? How should it be managed? Should it be managed through an independent organization or multiple organizations? For sure, it's important that the space actors have access to it and trust it. Then how much risk do we want to take for space asset and access to space? Should there be specific criteria set for specific missions, or for all assets, or for should the risk tolerated by some organization be specified like as a more an international norm, or should it be more mission specific? For sure, one of the key elements is the quality of the data. We need trusted sensors. They're essential to enable and support decision making. We rely a lot on the US right now. There are now multiple actors that are capable to provide sensor data. We expect even more actors in the future. Some key elements in that: calibration of sensors, data quality certification. So it's great to benefit from all kinds of different sensors, but we need to understand their quality, their calibration, so that we can have common use of these and improve in the end decision making. Operational conjunction analysis and decision making requires experience, stability of personnel, and so on. So this is an important skill for future, in the future, as we see more and more assets in space. Like I mentioned earlier, risk tolerance may vary from different missions or organization. In the end, the decision always fall with the operators so far. But again, should there be guidelines or standards? That remains to be seen, but should probably help the overall decision making. There are already multiple non-government actors with capabilities in our sensors that are operational or in development. We can think of Exoanalytics, Leo Lab, or I'm sure you've seen recent announcement from North Star. So a lot of potential with non-government sensors are upcoming. Something, should we create, or should we have a framework or an architecture for space domain awareness? For sure, developing that will involve multiple players in Canada. It is a multifaceted problem, or it should cover multiple aspects. It should include policy and regulation aspects, as well as technical and operational aspects, covering space observation, ground observation. How do we handle data and perform analysis, information services, or how can the information be provided, and as always, making sure we continue research and development in the field to be at the forefront and develop a new, better knowledge. In conclusion, I think we need to remember that space is free for all, but the access now is increasing exponentially, and how can we cope with that and make sure it remains free and easy and accessible to all? So that requires a collective action, and it's a multi-variable problem. It's not just a purely technical problem, nor it's just a policy problem. It covers many aspects, and that's why the handling it may be complex. It requires multiple actors. International and national coordination is key, and it must continue. There are several international forums in which Canada participate, and makes sense to continue. We need also to have good discussion or good national coordination within Canada. Should all of this become, be based on voluntary effort or legally binding measures? Overall, there is a need for a consensus. And again, the multiple actors in the government of Canada have a stake, you know, CSA, DND, GAC, ISED, and ARCAN. So hopefully we can have a lot more discussion on that. Also, non-government space activities and capabilities are increasing. Those are also key players, and they also have a stake in it. From an industry perspective, you know, I've been told many times, you know, industry prefers predictability and a level playing field. So Canada, as well as other nations, need to be mindful of that and make sure that any action are there to taking into account industry considerations. And you know, all space actors, whether they're government, non-government, national or international, they have a need for such information. And I guess this discussion today will help elevate the discussion and have better understanding on what are those needs, how can they be answered, and how can we go further in the future. Thank you very much.
Merci beaucoup, Michel. C'était très intéressant. So I have a few questions for you this afternoon. I'll start with the first one, and that actually, well, certainly from your CSA experience, but certainly that's going to call upon your GAC experience over the last 18 months. This comes from Mr. Kevin Brisky. One of the biggest issues the international community is facing for space debris mitigation is compliant with the existing guidelines. Canada requires the RSSA and spectrum applicants to respect these guidelines. Does GAC or ISED have compliance program, or are there programs being discussed right now that we could see in the future?
Compliance program, well, I guess the general idea is to rely on international bodies that have developed those guidelines. I'm not aware of a precise, something more precise than that. So the operators are requested to provide plans for mitigation or plan for end-of-life disposal or debris. At least they need to have considered it, and this is being analyzed when they submit their applications.
So just to clarify for our audience, that 25-year rule that when we put something up in space, it has to come back down within 25 years, how is that applied in Canada?
Well, okay. When people submit applications for a spectrum or RSSA, they have to perform an analysis of, depending on their orbit and so on, the nature of their spacecraft, will it re-enter within 25 years or not? There are multiple software that can be used to assess the lifetime in space, basically. So this is how this is sort of tackled. The applicant will provide an analysis of whether or not they comply with the 25-year rule. And based on the analysis and discussions, there are exchanges, and that's how it proceeds.
Okay, so just to be clear here, so if, let's say, a space mission or planner or someone who wants to submit something, the mission doesn't comply, they don't get their spectrum license or their RSSA?
Well, I cannot speak about ISED, but I can speak from my knowledge on the RSSA. So this would trigger discussions, further analysis, and eventually come up with some mutually satisfying resolution, basically. It's not a trivial problem. One can argue that there are different methods of analysis and so on. So most of the time, so far, at least, applicant meet the 25-year guidelines. When there are issues, again, discussions among the applicant and the government, and we can see where to go from there.
Okay. You raised a number of good questions during your presentation, and I was personally attracted to your slide number 12, where you said that, I can't remember the exact words, but SDA or would require investment. You talked about ground-based sensors, possibly space-based sensors. In that slide, you had the term space traffic management, or at least STM. And that got a number of us thinking, are there discussions within the CSA as to whether the CSA, that organization, should be involved be more active in collecting data for space domain awareness purposes, much like the European Space Agency is doing. ESA's got sensors that they're using for research and presumably operational purposes. Is that something that the CSA is looking into? And are there discussions where the CSA is thinking of getting involved in space traffic management?
Very good question. I'm glad I was away 18 months, so I'm not fully aware of everything that's going on at CSA. But I would like to answer that as there is a need for government coordination. I named the actors a few times already. So all of this would start with good coordination among the space actors in Canada to come up with an agreement on how to tackle this, how to best tackle it. And, I cannot answer more precisely than that for now. I don't think it would be appropriate. So, but we recognize, at least the people around this forum, with the burgeoning activities, there is more and more objects in space. It calls for more information to make sure that access remains possible, safe and stable, not only for Canadian, but for the rest of the world. So there is a lot of attraction on that. And it's not the problem that one single nation can resolve. So a lot of dialogue internationally is required.
Okay. Thank you very much for that. Actually, I'll put you on the spot, and I'm throwing this question to every participant. I'd like to hear your opinion offline. Who should take the lead in Canada? Your opinion. I realize that it's not like a formal official CSA position, but based on your experience, you've got significant experience in the field of mission operations. We'd like to hear what you think.
Yes, you're putting me on the spot. I think it's a multifaceted aspect. The lead needs to have knowledge of all, the military aspect, the foreign policy, the civilian consideration for industry, the growth, and so on. So saying one lead right now, I'm not sure. It really needs close coordination. And in fact, Canada could lead that with the government, with proper discussion and involving the key space actors in Canada so that we can come up with a consensus and efficient approach for that.
Okay.
To be not more precise than that, but I think going one side or the other is too early. I cannot do that today, basically.
Okay. Well, thank you very much. I've got one last question before we break until 3:15 or 15:15 for the military types in the audience. And it's from Charity Whedon from ASTRO Scale US. So most of you will have seen the comment she's put up on the chat. She's asking essentially, so far there have been instances of Government of Canada spacecraft that have not abided by the 25-year rule. I know of 2 of these satellites, NeoSat and M3MSat, for having personally worked on these spacecraft. And I believe Sapphire is the same issue. And as she adequately or accurately points out on her comments, these launches or these programs were approved before the IADC guidelines were published. So they were sort of grandfathered. And the question she has is, will the Government of Canada commit to add maneuverability on satellites deployed above 650 kilometers? I can provide somewhat a partial answer to that question. Probably not commit, but certainly the directive that exists today, and certainly when I was with the Surveillance of Space 2 Project Office and other missions that I've been sort of peripherally involved before that, is that from now on, meaning after NeoSat and M3MSat, Sapphire, satellites put up by Defense would have to abide by that rule. So after 25 years, they have to deorbit. So that was recognized. Whether this adds maneuverability with propulsion or some other type of technology remains to be seen, but certainly the intent and the directive is quite clear. For the second part of your question, Charity, I do not know the answer, and I'd be very happy to chat offline with you to just see who in Canada signaled that they were interested in what you've just stated. So other than that, we're going to break until 3:15. So go out, take a breath of fresh air. It's really nice out here if you're in Eastern Canada like we are. And we look forward to seeing you for the second half of this workshop. Thank you. Merci, Michel.
Merci, Don.
McCormack, who will be providing us Canadian perspective on space weather. I'll just wait till Dr. McCormack activates his screen. Oh, great, that's awesome. So I'll begin by introducing you. Dr. McCormack joined Natural Resources Canada in 1997 as a research scientist working on issues related to nuclear weapons testing and earthquake seismology. He has subsequently occupied successively more senior roles as a research scientist, research manager, and executive. Since 2014, he has been the executive director of the Canadian Hazards Information Service at Natural Resources Canada, responsible for a staff of over 60. Conducting research and operational monitoring and alerting for earthquakes, tsunami, volcanoes, and space weather, and providing Canada's mobile nuclear emergency mapping and forensic capability. Dr. McCormack is originally from Northern Ireland and has a degree in physics and a PhD in earth sciences from the University of Cambridge. So without any further delay, I pass on the mic and the screen to you, Dr. McCormack. Thank you very much.
Thank you very much. I've noticed at around about this time of the day, the Wi-Fi in my house sometimes gets a bit tired of all of the traffic. So I am hoping that it'll successfully stay up this afternoon. Good afternoon, everybody, and thank you very much for the invitation to come and speak to you today about what we're doing in NRCan at the moment on space weather and in terms of what some of our forward-looking planning for future activities should be. I should, at the outset, acknowledge my co-authors here, David Bottler, who's head of the Space Weather Group in NRCan, who I'm sure many of you know, and Robyn Fiori, who's another research scientist working within my Space Weather Group. And Robyn actually did the bulk of the heavy lifting in producing this presentation, so thanks very much for that. What we will cover today, it has something of a focus on space, but I'm not going to talk uniquely about space. I'm going to touch on some of the other space weather aspects of our work as well, because I think it's important to get an overall picture of where our prioritization is at the moment and how that's shifting likely to shift over the next couple of years. So to start with, really we look at what we do in the space weather domain from NRCan's perspective in three main areas. And of course, sometimes we get asked the question, why does NRCan do space weather at all? Why isn't it, I guess, the Weather Service? Or why isn't it the Space Agency? Or why isn't anyone else? And of course, it historically has evolved from our magnetic observatory program, which was established initially primarily for navigation and cartographic purposes. That's become much less important, and really the principal driver for this entire area of our business now within NRCan is to provide operational forecasting for space weather and the active research program that underpins that. So we do operate a fairly extensive ground-based a series of networks for space weather monitoring across Canada. We have, and we've progressively become, I think, more aggressively operational in the provision of 24/7 space weather forecasts, both for domestic and international users. Most recently, we've, in collaboration with a couple of foreign partners, stood up a 24/7 space weather forecast for international aviation through the International Civil Aviation Organization. And as well as the operation of the monitoring facilities, as well as the forecasting and nowcasting that we do, we also have a relatively expansive research program, both in-house and in collaboration with a number of partners, looking at the basic physics of space weather, looking at the phenomenology, and in particular, looking at impacts on critical infrastructure. This picture is something I'm sure this audience doesn't need to be led through, but it simply highlights a number of the critical infrastructure areas where space weather can have a significant direct impact, including some areas which are sort of key to NRCan's principal mandate, such as power distribution systems, pipelines, and so on. To give you an idea of what our ground-based observing systems look like, you see from coast to coast to coast, we have 15 magnetic observatories, everywhere from Victoria to St. John's to CFS Alert. And really that's the core of our constant monitoring of what the magnetic field is doing. And of course, because of where Canada is on the Earth, and because of where Canada is oriented to the magnetic field, those are key observations, not just for Canada, but for the entire global business of monitoring the Earth's magnetic field and its variations. We've been fairly aggressively rolling out a rheometer network across the country, and I'll touch a little bit on some of the work that we're starting to use that for. And then we also, for this program and also for a number of other programs, including the maintenance of the National Cadastre, as well as some work looking at active deformation in the West, we run a fairly extensive network within NRCan of GNSS receivers. And that's helpful for us to have the density of observations across the country to understand issues related to GNSS scintillation, which we'll touch on briefly too. So at the beginning, there's the research. And really it starts right back at the sun. We do have ongoing activities looking at the fundamental physics of the interaction of the Sun-Earth system and understanding the propagation of various phenomenology from the sun to the Earth and the interaction with the Earth's magnetic field. And then moving down in terms of the impacts of that into more applied areas, looking at magnetic effects on things like power systems and pipelines. We have, over the last decade or so, had quite a lot of work gone on looking at the ionosphere in particular, both from the perspective generally of radio wave propagation, with a few quite specific applications there, and increasingly with the concerns as to the level of dependency of more and more critical systems on GNSS infrastructure, making sure that we have an appropriate operational ability to be able to measure and model and understand the impacts of space weather on GNSS systems and on the precision of the signals coming out of that. We've looked at impacts on space systems. Originally, a lot of the work was focused on geostationary satellites. Again, the last few years, we've been looking at highly elliptical orbits and continue to do some of that work at the moment, in particular in support of some of the proposed new satellite missions, in particular the Environment Canada's proposals for a Canadian weather satellite, which would be sitting in such an orbit. And then research into improved methods of modeling and forecasting, including looking at advanced techniques such as machine learning and artificial intelligence for handling our ability to do timely and accurate long-term forecasts for space. A lot of partners. We're a relatively large group by Canadian standards, but certainly we don't have anything like the capacity internally to do everything. So a number of you will see yourselves listed here as partners, either government, or industry. These, in the case of industry, what we've done is really only indicate here those people that are truly partners, in the sense that there's a two-directional flow of information, of science. There are many, many other industry groups that we work with, where perhaps we're providing them with customized data or customized information for their operations, but it isn't quite a two-headed partnership in the same way. Number of the universities, these are probably the largest and most significant university relationships that we have, although we do have relationships with quite a number of other universities as well. And in particular, each year we bring a relatively large number of students in to work with us on joint projects related to space weather. And then internationally, I mentioned the KO project that we have running now with Australia, France, and Japan. We have a very long-standing and very close working relationship with a number of United States partners, in particular with the USGS and NOAA, and a number of other countries as well. So really the focus, the core of what we do is our space weather operations. It's this idea of taking all of our observations, taking the information from our research and putting them together to produce space weather forecasts. And I'd encourage those of you with interest to go look at our Space Weather Canada website, which is the sort of central hub for a lot of that information. And that, of course, gets disseminated then to those people that need that information for their own operations, whether it be government, critical infrastructure operators, or others. So turning now to where we're going rather than where we are or where we've been. We are, of course, and the purpose of this slide was to remind me to mention that we're coming out of the bottom of the activity minimum, the bottom of the 11-year solar cycle. So things should start to get a little more interesting for us in the Chinese sense over the next few years as we head towards the peak of the cycle. But we're constantly striving to improve the space weather monitoring, looking at ways of densifying our networks, taking advantage of better instrumentation. We're looking at new magnetometer systems that are coming on board. There are some low-cost systems now which are using quantum effects, which we're studying, and a number of other potential avenues to improve either the cost effectiveness of our systems or to be able to densify the network so that we can have higher precision input observations into our models. Improving the operational services themselves. And I would note in this that although we only own ground-based systems, we do make significant use of space-based systems as well in order to provide a full picture of what is going on in the space weather environment around the Earth. And active work continues to, as new systems become available, as new platforms come online, to integrate those into our operational systems. Looking at the forecasts themselves, we've done a lot of work the last couple of years to improve our numerical forecasting, by analogy, really, with the type of numerical forecasting that's done by our meteorological colleagues, but in a much more significantly complicated environment. So we've made some fairly significant strides in this area in terms of being able to better model at a very fundamental level the Sun-Earth system and be able to better understand, better predict, and better track what goes on there. The challenge now that we're faced with is operationalization of that. So transitioning from models which work fine in a research mode to models which can be implemented in an operational way. And one of the key requirements for that, of course, is that you've got to be able to get 24 hours of modeling done within less than 24 hours. Otherwise, it's not much good as a forecast. So that gets us into much deeper into the world of high performance computing than we've really had to worry about before. So that's an active area for us right now. Mention in passing, because there's military audience here today in part. We're doing quite a bit of work in support of DRDC's Over the Horizon Radar program. That's driving us to do a lot of HF radio observations particularly in the high Arctic in order to better understand and better characterize the radio propagation environment for that mission, but also for a number of other civilian missions as well. And as I've mentioned a couple of times in passing, we continue to work to improve our ability to forecast GNSS scintillations. This is something where we see that this is going to become increasingly important. There are drivers within our own department, in particular our own Geodetic Survey and Surveyor General branch, are starting to take a significant interest in the business of providing precision location information for autonomous vehicles, whether they be terrestrial or marine, and the understanding of the scintillations and understanding of the potential errors that can create for that positioning is something that's going to be critical in terms of moving towards live operational autonomous vehicle systems in Canada over the next 2 years. So satellite missions, we've had a quiet couple of years recently because there hasn't been a lot of satellite work going on. But it's, as I say, it started to pick up again just in the last 12 months or so with the proposals for a Canadian weather satellite, or a satellite mission, which would occupy some of these highly elliptical orbits that some of our research scientists have extensive experience modeling and making observations in based on work that was done to prepare for previous missions. And that also has fed into, and we anticipate will continue to feed into the details of the satellite design, because some of these satellites, because of the nature of the orbits, they're spending significant time in fairly unpleasant space radiation regions, and being able to predict what the radiation environment is like for the satellites is going to be critical for their operation. So that's more or less it in summary, where we are and where we're going. It's an important area for us. I'm very happy to hear the interest that's been mentioned in a number of the talks about space weather. I'm very pleased to hear that it's recognized as a key piece of our considerations around space-based infrastructure and situational awareness. And we're certainly happy to contribute to those conversations as they move forward, not least because we really do, I think, in order to properly take advantage of some of the opportunities that our own research work has created and improved knowledge about space weather has created, we really are going to need to step up our operational robustness in terms of some of our monitoring networks. And of course, that's going to cost money. So over the next decade or so, we'd see a continuing trend to improve our space weather services for you and for the other Canadians that need those services, both through enhanced monitoring capabilities, but also a continual process of new research, which improves all aspects of our activities transitioning into operations. And with that, I will open it up for any questions or comments. Thank you.
Thank you very much, Dr. McCormack, for this very interesting presentation. Our first question comes from Michael Maloney, and he's asking, well, he's pointing out a fact that aren't satellites to some degree in orbit are all space weather sensors of some sort. His question is, operators know the disturbance, torques, and velocity changes in their spacecraft. Can you use this data to monitor space weather? If not, is that something that might be feasible in the future or desirable for that matter?
Yeah, so I think a couple of answers to that question, and then we can take the details of it offline. There are a couple of dedicated satellites, as most people know, which have been launched more as science missions rather than as operational missions over the last couple of years to collect data specifically to improve and enhance and complement the ground-based systems for space weather. There are also a number of satellites which do have magnetometers on board, which of course are directly useful. And part of the discussions that we're having now in terms of the potential future Canadian meteorological satellite is the extent to which the mission package itself, in order both for science purposes, for enhancing our understanding of what goes on in these environments, but also for protection of the spacecraft itself, the extent and what types of instrumentation packages it makes sense to carry on board from a space weather perspective. But it is a good point, and certainly it is something where we have done work in the past looking at the impacts of space weather on satellites. Telesat, for example, there are a number of known cases where there's been a very clear association between significant space weather events and direct impacts that historically have happened to some of their operational satellites, which have actually caused, in some cases, a total loss of satellites. So it's an area which has been of much attention in the past, not a lot of focus in the last couple of years, but it seems to be coming around again.
Okay, that's interesting. I'm just thinking, and this is, again, myself, a personal, certainly not D&D vision, but with the prospects of Surveillance of Space 2, the SATCOM projects, and the other military, satellites. I mean, there might be opportunities there for, for data or space capabilities to be exploited for that purpose. One question that I have is, I was actually, knew very little about your office and your organization before I actually found an article online a few weeks ago about it. In your presentation today, you talked about a lot of the capabilities and the service that you provide. And I'm wondering how much of these services and capabilities that you have mostly emerge from requirements that your own staff have come up as they do their research versus requirements that you're getting from outside agencies. Are you getting formal requirements from, let's say, D&D, CSA, even industry for that matter?
Yes, we do, and we'd like to think that the answer is very heavily weighted towards the latter and not the former. That what we do, I think, what we have done over the last couple of decades has been very much in response to what have been identified as either gaps in knowledge or information that's needed, or requirements, upcoming requirements for particular users. One example I'll give, it's not a space example, but we've worked extremely closely with a significant number of the big power companies in Canada in order to really get a proper handle, not just in terms of how to respond operationally, tactically, if you like, to a space weather event while it's going on, but right back to the design stage of large transmission lines, so that at the design stage, those lines can be engineered in such a way that they're intrinsically more robust to space weather events. There's very little of our work, I would say, that isn't driven by being able to draw a straight line between the work itself and a particular user requirement. And I mean, I take the opportunity again to mention that, much of the most impactful work we've done has been directly in response to problems or challenges that critical infrastructure operators have, or that other government departments have. We think we have a pretty good handle on a lot of those, and good, active, healthy cooperative relationships with many. But anybody that, if they're not aware of what we're doing, or they're not as aware, we're in normal times always happy to entertain people at Anderson Road and show them around. And even in these not so normal times, we're still more than willing to have the conversations. It's a big part of what we do.
Okay, Thank you. Actually, I guess we just got a question from Mr. Peter Boone, but basically you've already talked about that, alluding to the Carrington event. So your work essentially is aimed at not preventing these types of events, but protecting against such events, right?
Yeah, it wasn't really, I mean, Carrington event's a long, long time ago. It was really the 89 event in Quebec that really kind of got the ball rolling. And probably if you take a sufficiently long historical view, you know, that was about the point where our program stopped being measuring the magnetic field for on maps and started becoming measuring the magnetic field because of its impact on infrastructure. There had been historical work done before that, but you know, that was probably the breakover point, because that was a point, I think, where everybody realized that this was something that people had to start taking seriously.
Last question from Trevor Antefave. What mechanism does NRCan have in place to request support for orbit selection?
I actually have no idea how to answer that question. I don't know if either David or Robyn, if you have anything, but to my knowledge, I don't believe that there's anything in place to look at that at all.
So there's no formal, I guess, mechanism, but informally, if we reached out, and actually, it's a great question. I just a year and a half ago, I used to work for Trevor as the PD for Surveillance of Space 2, and I never even thought of, you know, approaching NRCan or thinking about space weather, but that's obviously.
Oh, okay, sorry, I apologize. I slightly misunderstood the question. And if you're asking, you know, what mechanism is there for you to come and ask us for help from a technical perspective? Well, you know, you've got my coordinates, you've got David Butler's coordinates, you've got Robyn's now. Pick up the phone, send us an email, and we'll get the conversation started. We're not that formal. We don't need to sort of respond to formal tasking. We've worked closely with DND in the past on their previous polar orbiting satellite missions and the design of those, and we did a lot of work with DND looking at what the space environment would be like and doing hazard calculations for those. That capacity and expertise is still there, but I mean, the short answer is if you have a space weather question or a space weather challenge, just pick up the phone and or drop us an email, and we'll be happy to talk.
That's great. Thank you very much. Thank you very much for your presentation. Before you sign off, actually, I want to reiterate, usually when we think of space situational awareness or now space domain awareness, a lot of us in the past, we think about just the space segment, but SDA is a lot more than that. It's got the space segment, the network. It's understanding not just what's happening in terms of human activity, but the environment, the impact on those assets in space, but also on our, infrastructure on the ground, as Dr. McCormick said, in '89. I remember that storm. It was, I lived in Montreal in those days, and I really remember the impact. So it's got significant effect. So SDA is a lot more than just the nice shiny satellites. It's the whole environment and its impact on society. So with that, I'll conclude. Thank you very much. We'll now proceed with our next talk. And I'm actually impressed that we're actually doing a bit better on time than I initially expected. So you might actually have an earlier shut-off time this afternoon. So our next speaker is Major Lindsay Holmes from the Canadian Space Operations Center. She's currently the Space Domain Awareness Flight Commander at the Canadian Space Operations Center. She's an Air Combat Systems Officer by trade, with experience in search and rescue and operational testing and evaluation. Major Holmes received her Master of Science in Astrophysics from RMC in 2013, actually the same year that I received my PhD, so we're probably at the same graduation ceremony. And she continued on in a faculty position in the Physics and Space Science Department, teaching mainly astronomy and space science courses until 2016. So we were actually colleagues in that department during this time. She's since been in CANSPOC since 2018, and unless things have changed, I think on the part-time, she's also doing her PhD in astrophysics And I raise my hat to you because I don't know how you can maintain a full-time job as busy as you are and keeping on with your studies. So without any further delay, I give you the floor, Lindsay. Thank you.
Thanks, Don. I will share the presentation for you guys. That's going. There we go. Yeah, thanks, Don. So assuming you guys can all hear me okay, let me know if you can't. So as Don mentioned, my name is Lindsay Holmes. I am currently at CANSPOC as the Space Domain Awareness Flight Commander. Up until this summer, we call that our operational analysis or our orbital analysis cell, depending on who you actually asked. So I'm going to talk a little bit today more on the operational side of SDA. I'm kind of bookended with Pascal Tremblay, who started us off on the DND side. So some of the things that I go over probably going to seem a little bit familiar. I'll try not to duplicate things too much. But again, more of a higher level overview of what's happening. There we go. So first of all, CANSPOC, what are we? What do we do? This is the Canadian Space Operations Center. So we work for the Director General Space, who is Brigadier General Adamson. He is also the Canadian Joint Forces Space Component Commander. And our job is basically to integrate or try to integrate space-enabled effects into operations. So how we do this is we try to provide this space domain awareness to our supported commanders. We have a lieutenant colonel in charge who's called the Director of Space Operations and Readiness. Now, I'm the last speaker today, so you guys have seen a couple different definitions of space awareness, space domain awareness, and how it applies. The one I'm going to be put up here was on one of the other presentations as well. This came from a memo in October 2019 from Major General Shaw in the US, who at the time was the US's Air Force Space Command's deputy commander at the time. Kind of kicked off our shift from just calling it SSA, Space Situational Awareness, to leading into the space domain awareness regime. So identification, characterization, and understanding of any factor, passive or active, associated with the space domain that could affect space operations, thereby impact the security, safety, economy, or environment of our nation. Now, this was a US general that came out with this. It still applies to Canada, obviously looking at it with a Canadian perspective. Now, this doesn't mean that SSA goes away or has gone away. SDA builds upon our space situational awareness. We still need to know where things are in space and what they are doing. But now we're trying to look at more of the more complete picture. I guess the second part you probably saw from Pascal Tremblay's presentation as well. So we're adding in intelligence, cyber perspectives, weather, space and terrestrial infrastructure. So as SDA, as our overall awareness of the domain, we're trying to take all of the little pieces of relevant information and putting them together to give us a good overview of what is actually happening. And on an operator's perspective, we want to make sure our operations can continue to be managed in a degraded space environment. Now, militarily, where do we come from as part of the Canadian Armed Forces? Why do we care? So you may have seen this before. A few years ago, the government came out with their defense policy, strong, secure, and engaged. And this policy specifically called out our space capabilities, indicating that the defense team will defend and protect our military space capabilities. So we're to work with allies, work with partners to ensure our continued access to the space domain and space assets. This is both for the military regime plus commercial as well. We want everybody to continue to maintain or to assure their access to the space regimes. So when our troops go deploy away from Canada, we want to make sure that our planes, our ships, our troops, that they're all able to operate effectively, even in a degraded space environment. And they depend on us at CANSPOC and other space experts to help them do exactly that, to provide them the information they need so that they can continue to operate. Now, I'll get into a little bit more detail of the space domain in a moment, but I just kind of wanted to show this little nice diagram to kind of depict, helps demonstrate about how we go about both obtaining and providing space domain awareness within the Canadian Armed Forces. So as I mentioned, at CANSPOC, we work directly for the Director General Space. However, we are co-located here in Ottawa with the Canadian Joint Operations Center, or CJOC headquarters, and we are responsive to the commander of CJOC for providing space effects, space domain awareness. As part of that, we provide this 24/7 space watch capability. So we have somebody that's on the CJOC run Canadian Forces Integrated Command Center watch floor 24/7. That Space Watch crew chief is able to provide, real-time or as close to real-time information as we receive it that can be then disseminated directly to the CJOC headquarters, to the CIFIC watch floor, to be able to be passed along to operators if needed. This also shows the external collaborations that take place, right? So in addition to our side with the CJOC headquarters, we also have routine coordination with the allied nations as well. So obviously we deal regularly with the US's Combined Space Operations Center, the CSPOC, other national SPOCs we deal with on a regular basis. And internally to Canada as well, we deal with industry collaboration. We deal with other government partners, other government departments on a regular basis, as well as internal to D&D collaboration. So there's the rest of DG Space, DRDC, who we deal with, the Sapphire operators, as well as the SATCOM Operations Center. Now, where we're heading is we're trying to become more and more involved and integrated with, for example, our planning functions. We need to make sure that everybody takes space into account sooner rather than later to get full perspective of what is happening in the domain, so that our supported commanders, whether it be the Air Force, Navy, the Army, that they can use this information to effectively manage and utilize their forces. So this is a little bit where we are now. So within the space operations, we use our SDA and CANSPOC kind of as a force enabler. So we have our assets that can do some, sensing, collecting data, ability to perform and take actions into account, to, we have our shield, we have our command to communicate back and forth and sustain. So innovation is continually outpacing both policy and procurement. There are constantly new technologies that consistently change these enablers that we have kind of on the screen. Modern militaries, modern operations, we're all heavily reliant on space capabilities for operations and power projection. And our adversaries recognize our dependencies on this space domain. Bringing it back to the strong, secure, engaged, protect, and defend, this mission is kind of a paradigm shift in terms of space operations in Canada. It's a forcing function for us to look at all of these operational limitations and try to improve upon it with the information that we have. And all of that goes against the counter space. So we want to make sure we have access to these things. So I'm going to go into a little bit. Again, this were kind of mentioned a little bit before about, why space domain awareness is so important for us for operations. And so that first main characteristics, again, if you've been around for many of these types of, space on orbit talks, you've probably seen some of these things before. So the first one is obviously the congestedness of space. Canada itself only has about 60 active satellites or so on orbit at the moment, a couple of debris. However, as I believe it was Michel Doyon who put up there, is the increasing number of active satellites on orbit, with a massive increase even in the last year. In addition, all of the debris objects and or natural objects that are in orbit that potentially are risky to satellites that are on orbit, plus all of the things that we can't track because they're kind of small. This chart on the top right kind of shows our progress or planned expansion. So if you think it's bad now, just continue thinking about the exponential increase in growth. So this is kind of where we are now with respect to our GeoInt. And then if we look at what's going to happen for the next few years, there's a massive number of new satellites, new constellations being planned. And this is only looking at one subset of satellites. This is not including any of our communications or GPS, PNT satellites, any missile warning, any new weather satellites coming, or science. What this also doesn't include, and which has been mentioned a couple times today as well, is our mega constellations. So I looked at the SatCat this morning from SpaceTrack, and as of this morning, SpaceTrack had 839 Starlink satellites on orbit. And that's a planned constellation of about 10,000 satellites. And that is only one of many such constellations in the works. Next is the space environment is contested. So the amount of potential malicious actors in the space domain, this is not limited to on-orbit warfare, so to say. The majority of threats are terrestrial based. The space domain is highly contested. You can Google examples and see in the news examples where people had their PNT or GPS devices suddenly showing them as being at an airport or an alternate location when they were really in the middle of a city. There was an individual with a personal jammer who got around his GPS ankle monitor tracker who disrupted airport traffic because he was visiting a girlfriend or a friend nearby. So it's not just state actors or adversaries. The domain is contested and is relatively easily contested. And I'll keep bringing it back to our strong, secure, and engage, defend, and protect. So from a Canadian Armed Forces perspective, our freedom of maneuvers is challenged. We want to make sure we have access when we need it. Similarly, our space superiority, our ability to use SATCOM, to use GPS, to use the space as we want to is challenged. And the better we understand what is going on within the space domain, and the better we're able to reiterate and pass that information along, the better we can understand these challenges, overcome them, and the better we can operate in these environments. So you've already seen this slide today. Pascal had it up. Just some of the systems that can exist specifically to disrupt or deny both commercial and military space systems. Disruption can be anywhere from a temporary reversible measure. Your handheld GPS isn't currently working or showing you at an alternate location. And they can affect spacecraft directly, or it can affect your ground-based systems that they rely on, or prevent an operator from working or from providing valid information. This is all operational space domain awareness. So providing the details of what our military or our forces might encounter in various areas helps them be prepared to operate in these degraded environments. And again, yeah, so the threats or degradation can be space-based or Earth-based. Traditional and cyber belongs in there as well. The third kind of thing on the space domain side is its competitiveness. And again, this has been brought up a couple times, but again, adds to the complexity of the situation. This slide kind of adds to or helps bring a little bit more context, I guess, to my last couple of points as well. The competitiveness kind of brings a multiplier to what is going on. There's this non-linear correlation factor between the number of entities that are involved and the complexities of the domain. Years ago, the space domain was dominated by two main entities. You had the US and the USSR militaries. They were really the only actors in space. You can see from the plot now, that is not the case. There are many countries within the world. There are a significant number of commercial entities that are involved in the regime. And it just makes the overall space domain a little bit more complicated from an operational perspective. Now, these three kind of components to our space domain are rapidly changing and rapidly converging, kind of giving us a fourth little C in our little discussion here. As all of these opportunities and growths continues, these lead to associated risks outside of those previously mentioned with the contested regime. So they directly apply. So for example, the more assets, the more items there are actually in orbit, well, the higher risk potentially of collisions as there's more things in orbit. So some of these things are, makes us as operators vulnerable for what we're doing, because we need to pay attention to what is happening within the domain so that we can mitigate or try to counter some of these vulnerabilities. Now, I also stole a couple of these slides from Pascal Tremblay. I'm not going to go in them too much, but we are going to frame them a little bit more, I guess, in the operational perspective. So I've already discussed a little bit of space situational awareness and the shift from SSA to SDA. SSA itself has not and is not going away, despite moving into the SDA terminology a little bit more. In order to find or follow that policy to defend and protect, we need to ensure our continued access to space. Well, we need to know where things are. So internal to CAF and Canada, we obviously have the Sapphire system and NeoSat that's been previously brought up. Upcoming contributions will eventually be our Surveillance of Space 2 project when it comes into effect as well. These are our kind of contributions back into the US's space surveillance network, which helps provide us some of that SSA data that we can then apply some of those other facets to get our good space domain awareness. That just goes in showing a little bit of what's upcoming with the SFS2. And again, slightly version of the slide that Pascal had, but to when we talk about space intelligence, so we do have a couple military space intelligence professionals within CANSPOC itself, in addition to partnerships with our allies, in addition to information intelligence we get from our other departments, from commercial partners. Again, SDA is a compilation of all of this information. We have the SSA of where an object is, and now we amplify that with intelligence, with the data that we're getting from other sources. On our perspective, what are we actually thinking about when we look at another object in orbit? Well, what is it? What is that satellite? What can it do? Is it coming close to something I care about? Even if I just care about collisions, do I care about it spying on me? Do I care about it preventing me from what I'm doing? Do I care about it running into me? Is it planning to do something? So is there an intent? Is it, again, whether that intent is you know, a malicious or hostile potential actor, or is it an accident because it happens to be close and the frequency bands are a little bit overlapping unintentionally, providing some interference? How will this thing, whatever it is, does it have impact on operations? Is it going to prevent, if there is, you know, interference, which happens regularly, purely by accident? Sometimes it's, you know, commercial accidentally interfering with themselves using slightly different wavebands and whatnot. But is that disrupting our communications? Do we need to move to a different band? These are all the kind of things that we try to look at to get our better perspective of what's happening. Now, I only spoke into more detail about a couple of these different facets into space domain awareness, trying to focus a little bit more about pushing this data down to the operators, to our supported commanders, so that they have what they need. That doesn't detract from the usefulness of any of the other aspects. We use space weather regularly. Is the outage on a particular satellite because we're having charging? Did I need to reset my systems? We look at cyber factors. Are my systems, are my links at risk because of cyber? They're all relevant. It's all an aggregate of all the little pieces of data and information that you can gather that's put together to get a good perspective of the domain. So I bring up this diagram again because it is important, and even only to reiterate a little bit that the information that we receive from all of these entities in here, plus more that aren't on here, they all contribute to our space domain awareness. Without the data, the information that we get from all of the different sources, our awareness is not complete. And we strive, obviously, to make that as complete as possible. Everything that we get from our partners directly impacts our consolidated relevant picture that we we try to provide to space users. Now, this was kind of the CAF current into the future, but what is the future of SDA and the CAF? And the reality is we need to do better. And that's kind of been a theme that a couple other people have mentioned as well. So the space domain is continually evolving. It is expanding. Technology is improving. There's more actors. We basically have to get better at everything. We are continually working on our partner integration. And that's not just our partnership with the US or with our other allied nations. That includes working more with our other government departments, working with the CSA. It includes reaching out, making sure we have those discussions with Telesat, with MDA, with our other commercial partners, for example. That's a help to get our more information ingested to get better awareness. But then we also have to get better operationally to disseminate that awareness out. And so we have to work better at our CAF integration. So again, I think Don or somebody has mentioned it's kind of a learning opportunity for people about what is out there. And it's the same thing within the military. It's that outreach. Why do you care about space? Why should you care about space? We can help you get space smart, provide you the information you need basically to our operators to improve what they're doing, how they are operating. So we need to get better at doing that, at getting better at everything. Our dependence on space isn't going away, and our growth and progress depends on us continually improving our space domain awareness. This workshop, all of the different conferences, the UK's SSA conference, the SSA operators workshop, all of these interactions which allow us to sit down and discuss SDA and some of these issues, which could be just communications issues. What are you sharing with everybody else? Only helps everybody improve their own awareness, which is better for all space operators in the long run. And that is all I have for today. So, questions?
Thank you very much, Lindsay, for your very interesting presentation. I've got one question that I've noted from Mr. Kevin Brisky, who thanks you for your presentation, by the way. He mentions, you stated that SDA applies to commercial as well. Could you expand on what you've stated? And I know we've heard from John from Telesat's perspective, but I think it's interesting to hear what the government thinks SDA should mean for the commercial sector.
Yeah, it definitely applies to commercial, applies to everybody. On a commercial entities, if not only looking at, for example, our SSA, our space flight safety, is something coming near my satellite, but that might be posing a risk to it. But is there something operating nearby that is going to interfere commercially, like with what the commercial entity is trying to do? Is it not everybody follows the rules overall, right? So you don't necessarily know what people are doing. So by having that domain awareness, knowing that, okay, there's something nearby, might help overall allows commercial companies to, I guess, support their users. So for example, if you are seeing, big one is, the interference on a frequency band. A lot of that is working on tracking down what is actually happening on that band. Is that space weather, or is it maybe something is close enough nearby that's using a similar frequency? That's not just the SSA knowing that something is potentially nearby, but you're taking that external data information about what else is there to help build your picture of what is happening to your satellite. Why isn't it working the way you're expecting? Space weather, adding in, is it charging? Is space weather affecting my satellite? Again, that all feeds into the space domain awareness of what is actually happening. So it's taking all of those little pieces together to give a perspective. Commercial companies, they obviously want to serve their users to the best of their ability. They are providing a service. Having that information or knowing, okay, it is a higher than normal space weather events happening in the next couple days. Maybe there will be charging events. They can anticipate those things. They know if there's an outage, they can potentially mitigate what is actually happening. And again, for some of those, like those interference effects, most of the time, those are just accidental overlapping of signal regimes, right? Like it doesn't mean that there's anything malicious or intentional or anything there, but putting the entire picture in perspective helps the commercial entities account for that and potentially go through a slightly different frequency or route it through one of their other systems, that kind of thing, that kind of perspective.
Thanks. I'm curious, how much interaction do you or your staff or your colleagues have on a day-to-day basis with industry?
It's growing. So internal to CANSPOC, we do have routine communications with industry. So there are some industry partners that we deal with on a regular routine basis. One of the intents or plans for the future is actually building up those relationships, building up those, or more formalizing, I guess, those relationships between us and some of our industry partners to help that data flow of information, to know back and to share stuff back and forth. So it's, again, one of those things that we need to do better on, but we are working on it. So it's not necessarily.
When you say industry partners, you're here to just make sure we're clear, operators, right? Owner operators?
Yes. Yeah, other owner operators, absolutely.
Okay. And then I guess one last question, and then we're going to sign off. It's getting late. But in your discussions with your colleagues, your superiors, and even members of your team, have there been discussions where the military essentially says, you know what, this part of SDA should be addressed by another government department, or should be done by someone else? This is not, well, we're doing it because it needs to be done, but this should really be done by some civilian entity. Or are there areas that are not addressed and you guys say, well, this really needs to be addressed in the future? Has those come up?
Definitely. Again, a lot of what we do at CANSPOC, although we're building into more, but a lot of what we started out for is doing things because nobody else was doing it and it needed to be done. So part of the growth isn't necessarily like CANSPOC or DD Space doing it itself, but finding who is the right person or who should be doing some of these tasks. We have relationships, for example, with the SATCOM Operations Center, which is, who manages some of our military SATCOM links. And we get a lot of the questions through CANSPOC of, what's happening, or can we use this, or can we take, is there imaging available? And part of what we do helps direct the users, the operators, to the appropriate location if it's not us. So even if it's not us doing it, part of it is the dissemination or pointing people to the right person. And that is growing and it's changing. So within the policy that came out a few years ago, the space regime within the military itself is expanding and planning to expand over the next few years. In addition, obviously, commercial and other government departments are also expanding their, expertise in the space regime. So as that expertise gets evolved a little bit more, there will likely be, more dissemination of some tasks or directing people to a different location. Exactly how that looks, I'm not sure. Definitely, we shouldn't necessarily be doing everything because you can't do everything perfectly. Right, so you do have to focus on your niche or your specialties, and you have to rely on your partners, both foreign and domestic, in order to get that picture, because everybody can't get that full picture all by themselves. It takes an army.
All right. Well, thank you very much for your presentation today. I really like your background, or the view from your house. I need to get.
Yeah, that's absolutely the view from my house, Don.
All right, so with that, I guess I'll actually thank again all of our speakers. What we got this afternoon was what I think is the education piece, or at least the piece that initiates the discussion. All of the participants that stayed with us until the end essentially got to see what the state of SDA is today in Canada, where we're seemingly going into the direction we're going into over the next decade. And the hope is that a future workshop, and the goal is hopefully next year, in conjunction with hopefully an in-person ASTRO conference, if not next year, the year afterwards. But in any case, to lead with an actual perhaps workshop where we're actually going to have group discussions. I personally feel, and this is, this is not D&D speaking, but this is the defense scientist, I think we need a national vision, a national strategy moving forward. There's a lot of activity happening, and as Lindsay rightly pointed, some things are not being done, well, appear, and someone need to take a leadership role. And going into the future, I think we need to perhaps plan this out and to make sure that there are no gaps. So with that said, I'll reiterate the fact that I've got some of your questions. I invite you to communicate with me at the end by email if you want to discuss, if you've got ideas. I'd certainly be interested in having ideas for focused discussion groups for the next workshop. And with that, I'll conclude and hand over the mic to Jeff. Have a great day.
Don, thanks a lot. On behalf of CASI and all our audience participants, I'd like to thank today's workshop moderator, Don Bédard, and panelists, Pascal Tremblay from DG Space, John Holland from Telesat Canada, Michel Doyon from the Canadian Space Agency, David McCormack, Canadian Hazards Information Services, and just concluded Major Lindsay Holmes from CANSPOC. Thank you all for sharing your insights during this very informative event. I guess we all are growing accustomed to the fact that the virtual environment does have its limitations. But if we all unmute our microphones for a moment, perhaps we can show our appreciation in the usual way. Much appreciated, everyone. So the CASI ASTRO 2020 virtual series of events seeks to provide the Canadian space community the opportunity to share a wide variety of ideas about space in a virtual space. Details about upcoming CASI ASTRO 2020 virtual series events can be found on our website. The next event in the series will be held next Tuesday, November 10th from 12 noon to 1:30 p.m. on the topic of Earth observation. Moderator will be Ray Nassar of Environment Canada. Many of you will be familiar with Ray. And will feature presentations by MDA, ABB, the Canadian Space Agency, and GHGSat. 2 days after that, on Thursday, November 12th, we'll present another 90-minute session, again starting at 12 noon. In this case, Space Situational Awareness, a sister event to this one, is the subject, and it will be moderated by Lockie Scott of DRDC. Presentations featured will include those from Space Strategies Consulting Limited. Some of you will know the principal of that organization. McGill University, and again, DRDC and the Canadian Space Agency. Additional online space events will be offered between now and the end of the year, covering CubeSats, and there'll be this will be an interesting session or sessions under discussion here with, it could be a slightly different structure. The idea is to involve a variety of student organizations, and we're working with CSA to develop a group that is related to the CSA CubeSat program. Planetary science and surface exploration, which is another topic that has fallen out of the ASTRO 2020 abstract solicitation process, and space exploration, which also came out of ASTRO 2020. And there will be a couple of other surprise events, so please stay tuned, and I hope we'll continue to satisfy your curiosity and your desire for learning more about your areas of expertise and others. Once again, I'd like to gratefully acknowledge the support of Defence Research and Development Canada. Their contribution, their financial contribution was a great help to us, especially this year when revenue streams, I guess, all over the place are under stress. And certainly CASI isn't the only one experiencing this. As the online event environment becomes increasingly familiar and ubiquitous, CASI will be offering the opportunity for corporate and institutional sponsorship of future events. I tossed myself my own segue there. If the elevated visibility we can offer is appealing to your organization, please let me know. I'd be very happy to hear from you. And we can design, we can structure an event in a much more free way in the virtual environment than would be the case if we were in a physical location. So we can perhaps be a little more responsive to the specific ideas you may have about how your organization can be featured most interestingly. Excuse me, thanks to my CASI headquarters colleagues April Duffy and Todd Legault for handling the sometimes challenging logistics that facilitate the virtual series. I hope we will cross paths again soon. Please be patient with the constraints of COVID-19 and keep yourself and everyone around you safe. Goodbye for now. Au revoir et à la prochaine.